Hello, this video is for Stat 110, Module 4, Part 1, and includes a discussion of the relationship between two categorical variables. We will also introduce how to use pivot tables in this set of notes. Okay, let's go ahead and get started then. So the material presented in Module 4 will allow us to investigate, measure, and test relationships between two or more categorical variables. The variables under investigation are going to be referenced using the following terms. So a response variable. A response variable is the primary outcome or variable of interest in an investigation. The other variables are simply called predictor variables. Sometimes the response variable is known as the dependent variable, and predictor variables are known as the independent variables. So let us consider some examples from Module 3 to help us understand the difference between the predictor variable and the response variable. So in Module 3, we introduced an example regarding the perceived risks of smoking marijuana for females and males in grade 11 from Fillmore County. We created a graph that looked something like this for that. The response variable for this investigation is going to be the perceived risk from smoking marijuana. The predictor variable is going to be gender. So when I create the plots like this, the predictor variable is always placed on the bottom of the plot. So for example, if I wanted to look at the perceived risk of smoking marijuana across grade levels, again, the predictor variable would be the grade levels here, and that will go across the bottom. And what's going up on the graph, up the y-axis, would be the response variable. Here would be the risk level from smoking marijuana. Okay, so let's consider our example for this section of the notes, and that's going to be a section of data from the Titanic. This does not include all the people on the Titanic, but it includes many of them. So I think I have over 1,300 people in this data set. All of these individuals were on the Titanic. The main variable that I'm going to be concerned about is whether or not they survived. And for this example here, we're going to consider the passenger class as the predictor variable. Here's just some background information about the Titanic and a picture of the different areas. The first class passenger cabins were up near the top, and the third class passenger cabins were down here near the bottom. Okay, so let's consider the following questions that could be looked at with this data. So we could ask ourselves what proportion of the passengers survived, or we could ask what proportion of the passengers purchased first class tickets. Now those questions require only the consideration of a single variable in the data set. So survived here for the first, and then also just the passenger class here for the second. On the other hand, if we ask questions such as what proportion of the first class passengers survived, then I'm going to need to consider two variables, or I'm going to have to look at two of the variables simultaneously. Or something like, does the survival rate of passengers on the Titanic differ by passenger class? The answer to that is yes, but this requires, again, looking at two variables, the passenger class and then the survived variable. The best way, or the easiest way, to understand the relationship between variables using a spreadsheet is with pivot tables. Here's the wiki entry for pivot tables. I believe that pivot tables are one of the most underutilized tools in spreadsheets. They are a powerful way to easily and quickly summarize the data in various ways. So some call that just slicing and dicing the data. Trying to figure out what kind of relationships exist in your data can be easily determined using pivot tables. So let us consider the relationship between passenger class and whether or not an individual survived. The response variable here is going to be survived. The predictor variable is going to be passenger class. And then the summary that I'm going to be using here is just a count. So how many of the first class passengers survived? How many of the second class passengers survived? Third class passengers survived, etc. Okay? So how to create a pivot table in Google Sheets. It's going to be similar in Excel, but I'm going to be showing you how to use Google Sheets here. So I have several screenshots here. That'll kind of take you through and show you how to create a pivot table. I think the easiest way is just to move over into this example in my spreadsheet and show you here. I've also created a video that shows you how to create the pivot table, the row percentages, and then the 100% stacked column graph. So the first thing is to highlight the data that you want to summarize. And I can do that by selecting the box up here in the upper left-hand corner to the left of A and above the 1 here. And then I'm going to say data and then pivot table. The pivot table is going to want to be put onto a new sheet by default. So let's leave that. Let's put that onto a new sheet so it doesn't mess up the data that I have. So on this first window, just simply select Create. Here I'm going to need to specify the rows, the columns, and also the values. And I do that under the Pivot Table Editor. So under rows is where I put the predictor variable, which here is going to be the passenger class. Under the columns, I'm going to be selecting the response variable, which is survived. You can see my table is starting to be created here. I don't have anything in the middle of the table yet, or in the heart of the table, and that's going to be specified by the values box. So underneath values here, I'm also going to be selecting survived. And what that does is obtains a table of counts for me. We can edit that table by making things centered if I want. I can increase the font size. I can make column A a little wider if I wanted. That's hard to do here with my cursor. There we go. Notice that it counts the number of blank rows, and I can deselect that underneath Filter. So to get rid of the blank rows, I need to add, I can add passenger class or I can add survived. If I do passenger class here, and then from the drop-down menu, I'm going to want to deselect blanks here. And what that's going to do is remove that blank row for passenger class. I could also do the same thing with survived, just remove the blank column from survived. So if I deselect blanks here and say OK, and now I have my pivot table. From here, I can compute the row percentages, and I can also compute what we will consider, what we will call the 100% stacked column graph. Okay, so let's go back into the notes here and just consider the table that we created. Statisticians sometimes refer to this table as a contingency table or even a crosstab table, which just is short for a cross-tabular table. This particular cross-tab table has 3 rows in it, first class, second class, third class, and it has 2 columns in it. So we call this a 3x2 table. When we're determining the size, we do not include the totals there. So this again has 3 rows and 2 columns, which has a total of 6 values in it. So there's 6 values in the heart of the table here. So let's just consider a bunch of questions about this data. So how many first class passengers were in this data? So I'm going to be using the first class row there, and there's a total of 323. So that row total for first class would tell me how many first class passengers were in the data. Third class passengers in the data, I would just need the row total there for the third class row. How many passengers survived? Well, here I'm going to be using the columns instead. So if I'm asking about survived, that's going to be yes, so that's going to be a total of 500 individuals survived. Suppose your friend makes the following statement. More third-class passengers survived than second-class passengers. So what they're doing here is just looking at the 181 compared to the 119. Now that's technically true. 181 is bigger than 119. But one fallacy in that thinking is that the total for third-class passengers is much higher than the total for second-class passengers. So the survival rate is not necessarily higher for the third-class passengers. So we're not going to want to compare counts in these tables if the row totals are different. And most of the time, the row totals are different. So how do we overcome that problem? We overcome that problem by not comparing the counts, but instead comparing the row percentages. So let's look at the third-class passengers. How many third-class passengers survived? Let's go back up to our table again. There was 181 of the third-class passengers survived. There were a total of 709. So to compute a row percentage there, I would simply take 181 divided by 709. That's what we mean by a row percentage. So what proportion of the third-class passengers survived? That would be about 25%. Again, using the 181 divided by 709. I'm going to want to do that same calculation for the second-class passengers. So if I do that same calculation for the second-class passengers, I have a total of 119 out of 277. 119 divided by 277 is about 43%, it looks like. So now I can do a comparison of the third-class passengers against the second-class passengers. And we can see that the survival rate for the third-class passengers is somewhat lower than the survival rate for second-class passengers. These percentages here, again, are called the row percentages. The row percentages use the row totals here for each of their respective rows. They do not use the grand total of 1,309. So when computing row percentages, we do not use the 1,309 value, but instead the total for each of the associated rows. This here just shows you how to get the row percentages in Google Sheets. It's very easy to do in Google Sheets. I just need to select % of row under the Show As tab in my Values box. If I come over here and show you that, here's the Values box. I'm going to select % of row here. And that computes the 25% that I just computed and the 43%. Looks like the survival rate for first-class passengers is around 62%. So somewhat higher than both third class and second class. Getting the row percentages in Excel is a little harder, but can be done. I'm going to need to select on the field settings or the value field settings, and then under the Show Values As tab, I'm going to want to select % of row total. So here are some questions. Questions 1, 2, 3 here regarding those row percentages. So go ahead and hit pause and let you answer those. Okay, as I said, row percentages can be used when making comparisons across the groups. We're going to want to use row percentages, or we have to use row percentages whenever the row totals are different. So here is a graph of the survival rate. So this is those that survived here across first class, second class, and third class. And we can see that the survival rate goes down as I increase the passenger class. So there's a couple of questions here regarding that graph. Go ahead and hit pause and answer those now. Okay, typically when we create the graph, we don't just use the survived, but we would also show those that did not survive. So a graph is going to include all of the data, not just the survived data. And that graph would look like this here. This here is called a side-by-side bar graph, because each of the bars are next to one another. And this is created here in Google Sheets. Now, several individuals have studied how best to display and understand data. One individual is Michael Friendly, and he has devoted much of his work to understanding relationships for categorical data. He has suggested that instead of using the side-by-side version of a bar chart, that we use a stacked version of a bar chart. And all we do with the stacked version is just take the bars and stack them on top of one another. So my first class passengers would actually have the bars stacked. The second class passengers would have their bars stacked, and the third class passengers would have their bars stacked. Again, black here would denote not survived, and the gray boxes would denote survived. This here in spreadsheets is called a 100% stacked column chart. If you turn it and have this displayed horizontally, it's just called a 100% stacked chart. Now this graph right here is commonly known by statisticians as a mosaic plot. It's a very common plot, and we use this to understand relationships between two categorical variables. Again, these are based on 100% stacked vertical axis here, and the predictor variable goes across the bottom here. These are very common charts. There are a couple more questions here at the end regarding that chart. Okay, that does it then for Module 4, Part 1. Thank you.